In this video, I will solve this question. I will evaluate the integral from 0 to 2 of square root of 16 minus x squared dx. This is a typical trig substitution. Since a squared is 16, I'm going to take a equals 4. And so from the trig, we know that because we have square root of a squared minus x squared, I'm going to use 4 sine theta. Dx will be 4 cos theta d theta. And I know that the square root of 16 minus x squared will be 4 cos theta. Now in this case, because I have bounds, I have to know when x is 0, what is theta? When x is 2, what is theta? So I'm going to isolate theta here. And I'm going to get that theta is arc sine of x on 4. If you look at the video where I found the area of a disk, that's where the substitution came from. That's what the substitution is that we're really doing. We just write it this way because it's so much easier to play with sine than it is to play with arc sine and to make the substitution work. Alright, so I'm ready to do this. Let's check what the bounds would be. So let's call this I would be the integral. Now I want to know what my new bounds are. So if x equals 0, I'm going to plug it into this. Theta is arc sine of 0. Arc sine of 0, so the y value is 0. The y value is 0. That means 0. If x is 2, I'm going to plug it into this. Theta is arc sine of 2 on 4, which is arc sine of 1/2. Now the y value is 1/2. We're in the first quadrant. Pi on 6. Again, you can use your calculator for this, but make sure to transform them into exact values so you can actually write the integral. So my new integral, I had x equals 0, now I have theta equals 0. I had x equals 2, now I have theta equals pi on 6. Alright, so these are my new bounds, and this is why this video is here, to show you how to handle bounds in inverse trig sub. Alright, so now I have the square root. We know from the trig that it's 4 cosine theta. We have dx. We know from the trigs that it's 4 cosine theta. And so we're getting 16 cosine squared theta d theta. And we know how to integrate cosine squared. We've seen it before. So the integral is transformed into something doable with basic integrals using the trig identity. Then let's divide by 2. We get 8. 1 plus cosine 2 theta. And now we can integrate everything that's left. We get 8. We get theta. The integral of cosine is sine, but because I have a 2, I need to divide by 2 from 0 to pi on 6. So I get 8. If I plug in pi on 6, I get pi on 6 plus sine of pi on 3 divided by 2. And then if I plug in 0, don't forget to plug in zeros. Often it gives you 0, but not always. In this case, you'll get 0 plus sine of 0 on 2. You will get 0. But once in a while, it's going to give you 1 or 2 or something like that, and you'll mess up if you don't plug in 0. Alright, so we get, this will give you 4 pi on 3, and then 4 sine of pi on 3 is root 3 on 2, and so the answer is 4 pi on 3 plus 2 root 3. Alright, so don't forget the mantra. If you change variable, you must change your bounds. So the bounds must follow the variable. So at the point where I go from x to theta, I need to change my bounds from 0 to 2 to 0 to pi on 6.